polymer, what happens? There are the polymers expect the carbon atom. Okay, so that things all of you know that, and I would like to share here my presentation. Okay, all of you able to see the classification PPT? Yes, no?
Yes, sir.
Okay. So, say that what we see inorganic and organic polymers, and the classification of organic polymers we see that is based on the structure, linear, branched, and cross-linked. Then, based on method of preparation, we have to see the addition polymer. Example is a polyethylene, polypropylene, polyvinyl chloride, etc. Then we go for the condensed polymer, and in condensation polymer, there are the condensation polymerization, and there is small what ammonia, ethanol, etc. The example is the cellulose, protein, nylon 66, sterling, etc. Then last lecture we seen based on general physical properties, the organic polymers are classified into three groups: elastomer, thermoset, thermoplastic. So we have to see that is elastomers. Elastomers it is what? Rubber or rubber like
ब्रेक
polymer.
होतोय
And
तुला.
in that, hello? Any problem? Have any problem? Yes, I am audible. Yes or no?
सर वॉइस ब्रेक होतोय सर.
Okay, okay. So, I think but if any problem is say, then what we see in last lecture, that is the elastomers, rubber or rubber like polymers. When is condition called as an it is stretch condition, then called as a thin film. Okay, and we see that the softer non-heating natural is elastomers. The polymers are held together by weak intermolecular forces that can be easily overcome. If you cross links between the chains, help the polymer to regain its original position. Means you see the cross links are present in elastomers, and what they are held when it is elongated and it comes again its original position after removing the force. At that time, regain its shape, and for that purpose, cross links are present. Okay. So today we will okay. So there are the polymers which soften on heating and soften on okay. Means the polymer is like when you heat it, then it becomes soft, and cooling becomes hard. This different. Okay. You see this diagram here, all plastic bottles, spray bottles, okay, all kinds of plastics bottles are there. So this all type of the polymers is like a thermoplastic, because you know that when you heat the plastic bottle, then it becomes what? Softer, and when you cool it, then it becomes a stiffen. That is third one. So in the stiffen state, they can be heated or molded to any shape which is retained on cooling. Okay, so when you softer this polymer, you have to mold in any shape. Okay, and when you cool, then that shape is retained. Okay, so this process of heating, reshaping, and retaining the shape cooling can be repeated several times without composition or charge in composition of the okay. So you see that the number of times when you heat the thermoplastic bottles, then number of time you heat it and cool, number of time you heat, cool, heat, cool. What happens? There is no any decomposition. Just a change in the shapes are there, and whatever shape you want, that shape is there. Okay. So its structure is like this. Okay. And what's its important? It soften on heating and stiffen on cooling. So that is the most. Okay. Then the electrical forces of attraction are stronger than electrons, so heating is needed to soften it. Okay. So whatever intermolecular forces in thermoplastics polymer is stronger than what? Because you know that the elastomer, if it is elongated, then its chain length to increase this, but regain when you remove the forces. So that you know that. But in case of thermoplastic, force of attractions are what? Stronger than the elastomer. And that's why more heating is needed for soften them. Okay. Then the polymer chain are practically not cross-linked and are arranged in haphazard manner. Okay. So what is meant by haphazard manner? They are held together by weak van der Waals forces, so the chain can slide over one another on hitting. Okay. So what is meant by the haphazard manner? If you see this diagram, all of you see this diagram? The book arranged in what manner? It is not systematically. It is what any type. Okay, so you just keep on the book one above, and it is not in a well manner. Okay, and so haphazard manner means what? Not well arranged, or it is what more accurately it is called as a distal form. Okay, if you see the traffic, okay, the parking is there, and always number of students have vehicle, and you see the parking in our college campus area. So at less vehicle is there, it is systematic manner, but more vehicles are there, then it is what? Haphazard manner. Haphazard means what? Not systematic. Okay, so it is not a systematic. The polymer chain are practically not cross-linked and arranged in haphazard manner. So you see that in this case, here are cross-links are present, and that's why whatever polymer is present, it is systematically. Okay, but in this case, if you see this polymer is like this like this is like this. Okay, so all are what? Distal manner. It is not haphazard. It is not a systematic manner, and that's why it is called as a haphazard manner. So thermoplastic polymer in that crosslinks are absent, and that's why they are in haphazard manner. More simply, it is called as a non-systematic manner. Okay, all of you understand this one? Yes or no? Hello? Hello?
Yes, sir. Sir, PPT दिसेना.
Okay. Right now, you are able to see the PPT? Yes, no? Hello?
No, sir.
Able to see PPT? Yes or no? Hello? Hello? Are you able to see the PPT? Hello? Hello?
Sir.
Are you able to see PPT?
No,
Yes or
sir.
no?
No, sir. Only black screen is there.
Actually, okay. Just it. Right now? Are you able to see? Hello?
No, sir.
Now see. Hello.
No, sir.
What happened? It is see. Are you able to see?
No, sir.
Oh,
No, sir.
okay, just wait. Just wait. I have to rejoin the meeting. Okay. So don't anyone leave the meeting. Hello. Are you able to see the presentation? Hello. Hello? Yes, Amy. Sonal Bhagat. Are you able to see the PPT?
No,
No,
sir.
No,
sir.
sir.
No, sir.
So here that there is a sharing. And why not say? Now you see the PPT?
No, sir.
No, sir.
No, sir.
No.
Oh, it is. So what is it? Okay. Once again, I am trying. Are you able to see? Yes or no?
No, sir.
No, sir.
So I don't know, but I would like to share the PPT. Okay. Hello. 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 Okay. Just wait. Yes. 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 Yes.
Yes, sir. I can see.
Okay. You see the PPT?
Yes, sir.
Okay. So you see here, the arrangement of books is not a systematic manner. Then it is called as a haphazard manner. Okay, haphazard manner means not systematic. And if you see, this is the parking where four-wheelers you see anywhere parked there, two-wheelers are anywhere parked there, and it is not a systematic manner. And such like thermoplastic polymers is in the haphazard manner, that is not systematic. Why this is not systematic? Because not cross links are present there. Okay, all of you understand this? And these are held together by weak van der Waals forces, so the chain can slide over one another on heating. Okay, if you see, this is the chain or this is the chain. Okay, and if you heat it, then it becomes what? Softer. Means what? The chains are slide over each other. Okay, all of you understand this plastic polymer?
Yes, sir.
Okay. Then the last part of this classification is what? Based on general physical properties. First one is the elastomer, second one is thermoplastic, and third one is thermostic. In 30, what you observe here, the cross links are present. Okay, so it is well set, and that's why it is called as a thermosetting. Okay, so they are the polymers which change to an invisible and insoluble mass heating. Okay, so polymer like that, it is infusible. Means what? On heating, it is not a fuse or it is not insoluble. Okay, on heating. So these polymers are normally made from relatively low molecular mass semi-fluids, which on heating in mold from extensive linking between different polymer chains, forming three-dimensional network to become insoluble hard mass. Okay, so whatever the chains are present in the thermosetting polymer that are cross-linked with each other, and that's why cross-linking are present. That's why they forms what? Three-dimensional network, and that's why it is infusible or insoluble. Okay, and if you heat it, okay, then what happen? Due to this extensive cross-linking between different polymer chains, it forms what? Three-dimensional network, and to become insoluble hard mass. So insoluble hard mass is formed in this thermosetting. And if thermosetting are heated above the critical temperature, then these are converted into permanent hard form which cannot be recycled. Okay, so you know that some polymers are like that. When it is heated, then it becomes more and more hard. So that cannot be recycled. But thermoplastic is what? It is recycled several times. But these thermosetting polymers are not recycled, and it becomes a hard mass. Okay, because of the things are cross-linked with each other. And if you see these thermosetting plastics, links between the polymer chain stops movement between them. So this is the polymer chain. This is the green spot is a polymer chain. Okay, and these are joined by the cross-linking. Okay, and due to this cross-linking, they cannot move the polymer chain. So this is the monomer. Number of monomers comes together to form polymer. All of you know that. And due to that cross-linking, the movement monomers in the polymer is not allowed, and that's why when you heat the polymer, they becomes more hard. And if you go to heat more, that is temperature, then what happen? Hard mass is formed and it cannot be recycled. So these are the diagrammatic presentation of thermosetting showing number of cross links. Okay, all of you understand this one? So this is the classification of organic polymer based on their physical properties: elastomer, thermoplastics, thermostatics. Hello? All of you understand? Hello? Somnath Guru?
Yes, sir.
Okay. So then we would like to see the next part based on origin. Okay. So based on origin, these polymers, these organic polymers, are classified into many big groups. First one is natural polymers. They occur in nature. For example, cotton, silk, wool, starch, keratin. Okay. So if you see the structure of cotton, cotton is like this. This is the silk sarees. You know that the number of sarees made up from what? Simple silk cotton. Then wool. So everyone can do the wool. Then starch. Number of times you have to use the starch as an indicator for the chemical reaction. It is prepared from what? Maize, keratin, the hair. Okay, so hair is called as keratin. So these are what? Naturally occurring polymers, organic polymers, because in their backbone there is a carbon. Okay, so based on origin, the polymers, organic polymers, are classified into natural occurring polymers. The examples of natural occurring polymers are what? Cotton, keratin. While derived polymers means what? They are derived from naturally occurring polymers. The naturally occurring polymers is there. Okay. But from that, we can derive some new polymers. Then it is called as a derived polymers. For example, nitrate and acetate ester of cellulose. So all of you know that the cellulose is a natural polymer. But if we add nitrate as well as acetate esters in the cellulose group, then it becomes nitrate and acetate esters of cellulose. And this is derived polymer. The properties of naturally occurring polymers are chemically modified without changing their basic structure. Okay, means what? In naturally occurring polymer, we have to add chemically modified it, but without changing their basic structure. We cannot change their basic structure. And the example is a cellophane. So all of you know that the cellophane number of that is market in market. We wrapping paper is there, that is nothing but the cellophane. Cellulose rayon, so this is the thread of cellulose rayon, and all of you know that the leather. Okay, so leather is what? It is the basic part of the polymer, and without chemically that is chemically modified. Okay, then we can prepare shoes, bags, number of atoms which is derived from what? Leather, without changing their basic structure. So these are derived polymers. So derived polymers is also natural polymer, but it is modified. How the way of modification is there? Chemically modified. Okay, all of you understand it?
Yes, sir.
Then the last part of this organic classification, that is synthetic polymers, and these polymers are man-made or synthetic polymers. So synthesis may be carried out using monomers as a starting material. So all of you know that here synthetic reaction is there, and you have to add number of monomers. Okay, and through that there is a preparation of what? Polyethylene, polystyrene, silicone, synthetic rubber, epoxy resin, etc. So I am showing here the picture, and it is the epoxy resin. Okay, so you see the different colors of epoxy resins are there, which is formulated on the table. Then this is the silicones. Okay, if you see here is the carbon as a backbone chain, and silicon atom, number of silicon oxide is interlinked between this carbon chain. So this is called as the silicones. Polyethylene, all of you know that. Polystyrene, all of you know that. Okay, so these are the synthetic polymers. Nylon 66, these are what? Synthetic polymers. And this is based on what? Origin. Based on origin, the organic polymers classified into naturally occurring polymers, derived polymers, and synthetic polymers. So these are four types of what? Organic polymer classification. Okay. So if you see, based on structure, we have seen linear branched cross-linked polymer. Based on method of preparation, we see addition polymer, condensation polymer. Based on general physical properties, we have seen elastomer, thermoplastics, thermosetting, and based on origin, we have to see naturally occurring polymers and derived polymers and synthetic polymers. So the classification part of organic polymers are completed here. So all of you understand. If you have any question, please ask me. Yes, you have any question? Yes or no? Hello? You have any question? Hello? Hello?
Yes, sir.
You have any question?
Sir, what is mean by epoxy resin?
Epoxy resin. So resin, all of you know that there is a epoxide. Okay, organic and carbon and oxygen cross-linking are there, and it forms the solid type of support. So the resin is epoxide is from carbon and oxide ring structure, and through that there is a solid material part is formed, and that is nothing but the epoxy resin. Okay.
Okay, thank you, sir.
So after that, after this classification, this is only the classification of what? Organic polymer. Now we have to see the inorganic polymer, and this is the most important part of this topic, that is inorganic polymer. And on the basis of that, we have to see the different inorganic polymers. So all of you know that what is meant by inorganic polymers. The inorganic polymers generally do not contain carbon in their backbone. Okay. Simple definition of inorganic polymer is what? The polymer which do not contain carbon in their backbone. Okay. So inorganic polymer is defined as giant molecule formed by repeating structural unit except carbon is called as a polymer. Okay. What is definition? Simple definition, that is the polymer which do not contain carbon in their backbone, or the giant molecule formed by repeating structural units except carbon is called as a inorganic polymer. All of you understand? Yes, no?
Yes, yes, sir.
Okay. So these inorganic polymers are classified on several ways. Some importance are given below. So as like organic polymers, inorganic polymers also classified on different ways. First classification is based on type of atoms forming the skeleton. Type of atoms forming the skeleton. It is what? Homoatomic polymers or heteroatomic polymers. This is the first type of classification, that is based on forming the skeleton. If it is formed, the skeleton is formed from the same atom, then it is called as a homoatomic polymers, or it is called as a uh, homopolymers. Okay. And if the skeleton formed by the different atoms, then it is called as heteroatomic polymers or heteropolymers. Okay. Then second type of classification is based on the structure of polymer. Okay. So what type of structure of polymer? Expect the carbon atom in their backbone. On the basis of that, they are classified on basis of what? Structure. Then third one is classification is based on method of preparation. Okay. And that method of preparation is what? Condensation polymer, addition polymer, and coordination polymer. And these are the, I think, important type based on what method of preparation. As like organic polymer, you all of you know that there are only classification based on method of preparation. Two types is there: addition polymer and condensation polymer. But in case of inorganic polymer, based on preparation, they are classified into condensation polymer, addition polymer, coordination polymer. Okay, so these are the basic classification of what inorganic polymer. Okay, then from that first, that is classification based on atoms forming the skeleton, we have seen. And what is that? Homoatomic polymers. So classification based on the type of atoms forming the skeleton, it is also known as uh, Korshak and Mozoyaras. Okay, Mozoyo-Ras classification. Okay, the classification is also called as a Korshak or Mozoyo-Ras classification. So if you see homoatomic polymers, in these polymers, atoms of the same type are the skeleton or backbone. For example, P4, that is tetraphosphorus and octasulfur. Okay, so these are the examples, P4 and S8. So in that you have to see the four phosphorus molecules are arranged together, and these are the phosphorus. One atom of phosphorus considered the monomeric in it. So four phosphorus molecules are there, and that's why it is a sp4. Only phosphorus molecule are there. In case of sulfur, S set, you see 1, 2, 3, 4, 5, 6, 7, and 8 molecules are arranged together. Then it called as a homoatomic polymers. Okay. And what is meant by heteroatomic polymers? This type of polymers may have different types of atoms in the skeleton or backbone called as a phosphonitrile polymer or silicon. So this is the example of phosphonitrile chloride, and these are the polymer of phosphonitrile polymer. Okay, so it is what heteroatomic. Okay, all of you understand this one? Yes or no?
Yes, sir.
Okay, so what happened today? Electricity is not here, and my battery is only 1%. So today we will stop here. Okay, we will meet to next lecture to see the inorganic classification as well as the difference between organic and organic polymers. Okay, okay, all of you understand?
Yes, sir.
So today we stop here. Okay, thank you. I think next lecture on 12:10. Okay. So you have to join for next lecture. Thank you.
पटकन जॉईन व्हायला सांगा. कुणीतरी परत एकदा लिंक शेअर करा ग्रुप वरती. मयूर जगताप, शेअर द लिंक ऑन ग्रुप. Am I audible? आवाज येतोय का माझा? हॅलो, आवाज येतोय का? अरे बोला काहीतरी पटकन चला. Okay, in previous lecture we start Faraday's laws of electrolysis. In this we finish out first law of electrolysis given by Faraday, in which we see one relation: M is directly proportional to amount of current passed through it and at time t. If we focus on the principle regarding the Faraday's first law of electrolysis, the mass of an element liberated on electrode, that is, mass is liberated on cathode. The electrolysis takes place on cathode. The mass of an element liberated on electrode during electrolysis is directly proportional to how much quantity of electricity. We notify this by letter Q or I, which pass through the solution of an electrolyte. And for this we take simple example like if small m is the mass of substance deposited or liberated and I is the current in amperes which passes at time t, or the electroplating takes place at time t second, then according to first law of electrolysis given by Faraday, we make a simple relation. M is directly proportional to amount of current, that is I, and time t, that is M is directly proportional to I into t. If we make a constant, then the given relation we can convert M is equal to Z into I into t, and this Z, M is equal to Z into I into t. This Z is called as electrochemical equivalent, where Z is a constant and this constant is called as electrochemical equivalent. Imagine if we pass only 1 ampere of current at time t in 1 second, then M is equal to G. M is equal to Z. See what we tell, if we pass current only 1 ampere at time t is equal to 1 second, then M is equal to electrochemical equivalent, that is M is equal to Z. If 1 ampere of current is passed through 1 second, then M is equal to Z. This means that 1 ampere of current is passed for 1 second, then mass or amount of substance deposited or liberated is exactly equal to its electrochemical equivalent. And the standard electrochemical equivalent series is given in any electrochemical references. See again, if 1 ampere of current passes in 1 second, then amount of element or substance liberated or deposited is exactly equal to its electrochemical equivalent. The unit of the quantity of electricity is called as coulomb. I think in the previous lecture also we see 1 coulomb is equal to how much Faraday, and how we convert this coulomb into Faradays. Coulomb is the quantity of electricity passed when 1 ampere of current pass in 1 second. That is, if Q is the quantity of electricity, then according to first law of Faraday, Q is equal to if Q is the quantity of electricity. Again, see, the unit of quantity of electricity is called as coulomb. Coulomb is quantity of electricity passed when 1 ampere of current is passed in 1 second. Then, by applying first law of Faraday, Q is equal to I into T. The larger unit of the quantity of electricity is called as Faraday. 1 Faraday is equal to 96,500 coulombs. I think this also we see in previous lecture. The quantity of substance which is deposited or liberated when 1 Faraday, that is 96,500 coulombs of electricity pass in 1 ampere and 1 second, then this one is gram chemical equivalent. See again, the quantity of substance which is deposited, where deposition takes place, generally deposition takes place on the cathode. We have deposited 1 Faraday, here 96,500 coulomb of electricity is passed through an electrolyte. Here we see different types of electrolyte. If I want to electroplate a copper, then I am selecting electrolytic solution like copper sulfate. If you want to electroplate a particular cathodic rod by gold, then you take a gold solution or any ionic solution containing gold. They have choice to select different types of elemental or ionic solutions as electrolyte. It's called as gram chemical equivalent. And then electrochemical equivalent. I think in previous lecture we stopped here. Now today we focus on this electrochemical equivalent. What is meant by electrochemical equivalent? See here, electrochemical equivalent of a substance. These are the definitions are important in MCQ type of questions. Electrochemical equivalent of a substance. How we define this? The amount of substance deposited or liberated, amount of substance deposited or liberated when 1 coulomb of electricity or electric charge is passed through an electrolyte. If we pass 1 coulomb of electricity in electrolytic solution, then how much amount of substance deposited or liberated on cathode? This is called as electrochemical equivalent. It is represented by letter small z and SI unit is kilogram per coulomb. Again, we simplify this. when we pass 1 coulomb of electricity, the amount when we pass 1 coulomb of electricity, then the amount of substance or element deposited or liberated. How much amount is deposited or liberated? It is called as the Z or electrochemical equivalent. Here is one simple example regarding this calculation of electrochemical equivalent. See here, a current of 0.5 amperes was passed through a solution of copper sulfate. Here we take an example like copper sulfate as the electrolyte. For 1 hour, calculate the mass of copper. You all of have idea regarding how to calculate this. M is equal to ZIT. What is the formula for this? M is equal to Z into I into T. What is the T? Here they pass for 1 hour, then current is 0.5 ampere. No, there is no conversion takes place because it takes using ampere. Then time T in hour, we convert this in second into 36 or 3600 second. 1 hour 60 minutes or 1 minute is equal to 60 seconds, and hence we convert this 1 hour into 3600 seconds. Z for copper metal, that is electrochemical equivalent, given by example is 0.00329 gram per coulombs. We convert this into kilogram per coulomb. That is, we divide this by 1000, then it converted into 3.294 into 10 raised to minus 7. Then you can try to solve this example, how to solve a particular example, or what is the final answer regarding this. You can solve this example at home. It is very simple. This is the formula. W is equal to weight, or M is, you can take W or M. M is equal to Z into A into T. A is nothing but current in ampere. T is the time in second. Z is the electrochemical equivalent. For solution, W is equal to Z. You keep in mind only one formula, either M or W. W is equal to ZIT or M is equal to ZIT. Here they give representation of current in the form of amperes. And hence final answer is comes to be 5.929 into 10 raised to minus 4 kilogram. You can solve at home. After completion of this, now we focus on second law of electrolysis. How electrolysis takes place. In Faraday's second law of electrolysis, in first law we see mass of element deposited or liberated on a particular electrode depends upon how much quantity of electricity pass through it in particular time. दिलेल्या टाइम मध्ये किती अमाउंट हा इलेक्ट्रोप्लेटिंग झालेला आहे हे पहिल्या लॉ मध्ये आपण शिकलो. How much quantity of electricity or how much quantity of element deposited on particular electrode at a particular current, and time t is, that is relation M is directly proportional, or M is equal to ZIT, is given by Faraday's first law. Now we focus on second law. Faraday's laws are very useful for the determination of chemical equivalents of different electrolytes. Up to this stage, we focus on only one electrolyte. Now, Faraday's laws are very useful for determination of chemical equivalent of different electrolytes. Here we can see different types of electrolytes to calculate a chemical equivalent. Its usefulness is evident of the second law. How we confirm this, we can see in second law of electrolysis given by Faraday. According to second law, the mass of different substances deposited or liberated. Here, up to this stage, we focus on mass of only one substance. But in second law, we see mass of different substances deposited or liberated when same quantity of electricity pass through the different electrolyte. If we take three types of electrolyte, we pass a 1 ampere of current from all three electrolytic solution. The mass of different substances deposited or liberated when same quantity of electricity is passed through different electrolytes connected in the series is proportional to their chemical equivalent of masses. If we take different types of electrolyte and we pass same quantity of electricity through all these electrolytes, there may be 2, 5, 10, whatever may be. The mass of different substances deposited or liberated in the same quantity of electricity. Here we take example like 1 ampere of current we pass through different electrolytes. When same quantity of electricity is passed through different electrolytes, we take for example different types of electrolytes connected in series are proportional to their chemical equivalent of masses. कशाला proportional आहे? Their chemical equivalent of masses. See here we take three electrolytic solution and all these are connected to the external circuit. There is a battery. Anode is connected to negative terminal. Cathode is connected to positive terminal. On cathode there is a मी करेक्ट सांगितलेला आहे का? एनोड आपण कोणाला कनेक्ट करतो आणि कॅथोड कोणाला कनेक्ट करतो. जर कॅथोडकडे जर पॉझिटिव्ह आयन जर येत असतील तर कॅथोड कोणाला कनेक्ट केलेला असणार आहे? निगेटिव्ह टर्मिनलला कॅथोड असते, पॉझिटिव्ह टर्मिनलला एनोड असते. एनोड हा पॉझिटिव्ह टर्मिनलला आहे, कॅथोड हा निगेटिव्ह टर्मिनलला आहे. Here we take three electrolytic solution. Keep in mind, anode is connected to positive terminal, cathode is connected to negative terminal. On anode, there is oxidation takes place. On cathode, there is reduction takes place. Anode, there is loss of electron. This electron loss or given by anode or for reduction comes to or near to cathode, and there is a coherent layer of particular metal or element takes place on the cathodic rod, and we call it as the electroplate or electroplating of this cathodic rod takes place. Consider here three different electrolytes. First one is a silver nitrate, GMO3. Second one is the copper sulfate, and third one is aluminum nitrate. See again, silver, copper, and aluminum. These are not are this copper is from 3D series, and aluminum is from P block element, and silver is from 4D or 5D series. That is, there is no relation to all these electrolytic solution. That is, not all comes from one group, one series. There are some difference in properties also. See here, these three electrolytes, if we connect in series, and silver nitrate, copper sulfate, and aluminum nitrate in their aqueous solution. Now we dissolve these particular electrolytes in aqueous solution and connected in series. What happens? What is the definition or what is the statement regarding this? According to second law of Faraday, the mass of different substances, one is copper sulfate, other is aluminum nitrate, second is silver nitrate, that is three are different. The masses of different substances deposited or liberated. कोणावरती डिपॉझिट होणार आहे? ते कॅथोड रॉडवरती डिपॉझिट होणार. का होणार आहे? तर cathode contains or cathode contains negative charge on which there is reduction takes place. The mass of different substances deposited or liberated in same quantity of electricity. Here we take, for example, we pass a 1 ampere of current. Is passed through different electrolyte connected in the series. As we see, all of you see this, all electrolytes connected in the series is directly proportional to their chemical equivalent of masses. Chemical equivalent of mass for silver is somewhat different, for copper is different, aluminum is different. That is, all having is directly proportional to their chemical equivalent masses. जर तुम्ही कुठलेही इलेक्ट्रोलाइट एका सिरीज मध्ये कनेक्ट केले, त्याला एक्सटर्नल इलेक्ट्रिक सोर्स अप्लाय केला आणि इलेक्ट्रोप्लेटिंग झालं, तर त्याचं रिलेशन आपण काय सांगितलेलं आहे? मास जे डिपॉझिशन होणार आहे कॅथोड वरती, जे डिपॉझिशन होणार आहे ते कोणाबरोबर प्रोपोर्शनल आहे? देअर केमिकल इक्विव्हॅलेंट मासेस. देअर केमिकल इक्विव्हॅलेंट मासेस. आपण पुढच्या स्लाइड मध्ये पाहणार आहोत प्रत्येकाचं केमिकल इक्विव्हॅलेंट मासेस सेम आहे का डिफरंट आहे. Same quantity of electricity is passed through them. Then the masses of silver Ag, copper Cu, and aluminum Al deposited on respective electrode. जसा सिल्वर मध्ये दोन इलेक्ट्रोड आहेत, एक एनोड आहे एक कॅथोड आहे, त्या कॅथोड वरती इलेक्ट्रोप्लेटिंग होईल. कॉपर मध्ये सुद्धा सेम आहे, एक एनोड एक कॅथोड. पाहू शकता तुम्ही प्रत्येकामध्ये दोन दोन इलेक्ट्रोड आहेत. प्रत्येकाच्या कॅथोड वरती काय होणार आहे? इलेक्ट्रोप्लेटिंग होणार आहे. There is a formation of a fine coherent adhesive layer on the cathodic rod. This silver, here we take example like this silver, then copper and aluminum deposited on the respective electrode would be directly proportional to their chemical equivalent masses. कोणाला proportional आहेत? As we discussed in the statement of second Faraday's laws, the masses of different electrolytes deposited or liberated on the particular electrode is directly proportional to their chemical equivalent masses. आता इथं खाली रिलेशन पहा. According to Faraday's law, if exactly 96,500 coulombs of electric charge is passed, म्हणजे आपण काय म्हटलेलं आहे? 1 Faraday is equal to 96,500. 1 Faraday is equal to 96,500 कुलम्ब एवढा इलेक्ट्रिक चार्ज आपण पास केलेला आहे. आता इथं काय म्हणतोय पहा, सिल्वर इज डिपॉझिटेड वुड बी इक्वल टू, सिल्वर किती डिपॉझिट झालेला आहे, तर सिल्वरचं जर आपण केमिकल इक्विव्हॅलेंट मास पाहिलं तर काय आहे, 108 आहे. आता जर आपण फॉर्म्युला घेतला तर त्याचा फॉर्म्युला काय होता, AgNO3. काय होता, AgNO3. AgNO3 चा जर आपण विचार केला तर AgNO3 ला काय आहे सांगा मला. NO3 वरती कुठला चार्ज असतो, NO3 वरती असतो एक मायनस चार्ज, NO3 ला एक असतो मायनस चार्ज, Ag वरती एक असतो एक प्लस चार्ज. Ag वरती किती चार्ज आहे, एकच आहे, म्हणून 108 ला 1 वाढ केलं, नो प्रॉब्लेम. 108 इज देअर केमिकल इक्विव्हॅलेंट वेट. जेम कॉपर सल्फेट, कॉपरचं केमिकल इक्विव्हॅलेंट वेट किती आहे, 31.75. कॉपर सल्फेट CuSO4, एका SO4 वरती चार्ज किती आहेत, निगेटिव्ह 2 आहेत. These two negative charge is neutralized by placing two positive charges on copper. जर आपण कॉपर वरती जर 2 पॉझिटिव्ह चार्जेस दिले तरच तो कॉपर न्यूट्रल होईल. म्हणून आपण इथे काय केलेलं आहे पहा, किती आहेत, 2 कॉपर आहे, Cu++. 2 ला आपण काय केलं, 31.75 into 2 that is 63.5 divided by 2. एका कॉपर साठी आपण केलेलं आहे. If we take third, Al अल्युमिनियम नायट्रेट. कोण मला सांगू शकते का अल्युमिनियम नायट्रेटचा फॉर्म्युला, जरा पटकन सांगा. व्हॉट इज द फॉर्म्युला फॉर अल्युमिनियम नायट्रेट, व्हॉट इज द फॉर्म्युला फॉर, आपण 3 इलेक्ट्रोलाइट सोल्युशन पाहिले, कॉपर सल्फेट, सिल्वर नायट्रेट आणि अल्युमिनियम नायट्रेट. आता आपला फक्त अल्युमिनियम नायट्रेट राहिलेला आहे. कोण सांगते मला फॉर्म्युला, व्हॉट इज द फॉर्म्युला फॉर अल्युमिनियम नायट्रेट, पटकन बोलायचंय, चॅट बॉक्स मध्ये लिहिला तरी चालेल. अल्युमिनियम नायट्रेट, पटकन बोलायचंय. सीमा बाबर सांगा, सीमा बाबर. You can write in chat box what is the formula for aluminum nitrate. पूजा बाबर, दीप्ती धनावडे बोला. ओके, व्हेरी गुड. श्रेया हिरेकर, दीप्ती धनावडे करेक्टली रायटिंग केलेलं आहे. AlNO3. आता आपला पुढचा प्रश्न आहे, आपण कसं म्हटलं, कॉपर सल्फेट CuSO4, नंतर काय म्हटलं आपण, सिल्वर नायट्रेट AgNO3. आता आपलं काय, तुम्ही फॉर्म्युला एकदम करेक्ट रायटिंग केलेला आहे, अल्युमिनियम नायट्रेट. पण मला वाटतंय तो AlNO3 थ्रायस वेगळं दिसतंय ते. असं जर लिहिलं तर मी चालेल का, AlNO3 चालेल का, ओंकार जगताप, दिसताना जरा चांगला दिसेल AlNO3 लिहिलं तर चालेल का. मयूर देशमुख, अल्युमिनियम नायट्रेटचा फॉर्म्युला काय, मयूर देशमुख, मयूर जगताप, करेक्ट आहे का सांगा. AlNO3 थ्राइस फॉर्म्युला करेक्ट आहे, पण AlNO3 थ्राइस का, ट्वाइस का नाही, वनच का नाही, हा क्वेश्चन आहे आपला पुढचा. नंतर आपण पुढे जाणार. मयूर, now you are at, or all of you having QI basic students, try to see the logic behind how to prepare different types of formulas by studying valencies. श्रेया हिरेकर, आहेत का श्रेया हिरेकर, सांगा मला जरा, का आपण AlNO3 थ्राइस लिहिलेलं आहे, ट्वाइस का नाही लिहिलं, किंवा 1 टाइम्स का नाही लिहिला. ओके, व्हेरी गुड. जर if we focus on the aluminum, where is the location of this aluminum in periodic table. See here, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. This is first group. Second is the beryllium, magnesium, calcium, strontium, barium, radium. The second group. Then if we go to the third group, then boron, aluminium, gallium, indium, thallium, boron, aluminium, gallium, indium आणि thallium हे सगळे एलिमेंट आहेत. आपण त्याला 13वा ग्रुप म्हणतो किंवा थर्ड ग्रुप म्हणतो. बोरॉनचा जर ऍटॉमिक नंबर पाहिला तर किती आहे, हायड्रोजन 1, हेलियम 2, लिथियम 3, बेरिलियम 4 आणि बोरॉन 5. पहिल्या शेल मध्ये 2 इलेक्ट्रॉन गेले, व्हॅलन्स शेलला फक्त 3 राहिले. अल्युमिनियमचा ऍटॉमिक नंबर आहे 13, पहिल्या शेल मध्ये 2, दुसऱ्या शेल मध्ये 8, 8 आणि 2 10 राहिले, व्हॅलन्स शेलला फक्त 3. म्हणजे त्याच्या व्हॅलन्स शेल मध्ये 3 इलेक्ट्रॉन आहेत. अँड इफ it take 5 electrons from external species, then it completes its octet, and it is a very difficult task to take 5 electrons from other species, and hence it loses its 3 electrons very easily to nearest species to form a stable formula or stable inert gas configuration. A stable कॉन्फिगरेशन तयार करण्यासाठी तो काय करतो, दुसऱ्याकडून 5 इलेक्ट्रॉन घेण्याच्या ऐवजी स्वतःकडे जे 3 इलेक्ट्रॉन आहेत दुसऱ्या कोणाला देऊन टाकतो, आणि म्हणून आपण काय म्हणतोय, अल्युमिनियम शोज +3 ऑक्सिडेशन स्टेट. आणि म्हणून see here, aluminum their chemical equivalent mass is 9 into 3 Al3 plus 27, which are their equivalent masses of an element. These are the, then how equivalent mass of an element, atomic mass of element divided by valency of element, atomic mass divided by valency. This is the formula for calculation of chemical equivalent mass of an element. There is atomic mass divided by valency. The current of 96,500 coulomb is called as 1 Faraday. Charge after the name of this theory behind this all you study at SI basic level, and hence keep in mind only 1 Faraday is equal to 96,500 coulombs. There are some examples regarding this, how to calculate this. You can solve the example at home. I give this, or I transfer this presentation on your Google Classrooms. Now, a compound whose aqueous solution is decomposed into its component when electricity is passed through it is called as. सांगा जरा मला. Here we see a question. There is one MCQ क्वेश्चन. थोडेसे आपण एक 5-6 क्वेश्चन सॉल्व करूयात, लगेच आपण पुढच्या स्लाइडला जाणार आहोत. थोडे क्वेश्चन सॉल्व करूयात. मला करेक्ट आन्सर कोण सांगू शकते? ए कंपाउंड whose aqueous solution is decomposed into components when electricity is passed through it is called as. असे क्वेश्चन मी एमसीक्यू ला विचारणार आहे. दिस टाइप ऑफ क्वेश्चन्स आर आस्क्ड इन युअर एक्झाम. मला सांगा, चॅट बॉक्स मध्ये आन्सर देऊ शकताय. मयूर जगताप, इलेक्ट्रोलाइट, ओके. अजून कोण सांगताय? परत एकदा क्वेश्चन दाखवतोय. दोज हॅव नॉट सी प्रॉपरली दिस क्वेश्चन. अगेन आय रीड द क्वेश्चन. ए कंपाउंड हुज aqueous solution, ए कंपाउंड हुज aqueous solution, आपण जे सोल्युशन तयार करतो, इट डिकम्पोज आफ्टर पासिंग एक्सटर्नल इलेक्ट्रिक करंट इज कॉल्ड एज. The options are non-electrolyte, electrolyte, acid and salts. Ahrekar. Okay, electrolyte. Okay, this electrolyte answer is correct. You all having idea regarding this, how electrolyte or what is the definition from this electrolyte. Now the second, the unit of the quantity of electricity in SI unit, quantity of electricity, that is all have idea regarding ampere. What mass of calcium is collected on cathode when 1 Faraday of electricity is passed through it in the solution. कोण सांगू शकते मला? आता आपण एक पाहिलेलं पाहिजे, क्वांटिटी ऑफ देअर केमिकल इक्विव्हॅलंट ऑफ मासेस. कॅल्शियमचा ॲटॉमिक नंबर बघू, मला कोण सांगते का ते आन्सर? What mass of calcium is collected on cathode when 1 Faraday of electricity is passed through its solution? आपलं ते रिलेशन आहे, m is equal to z into I into t. 1 Faraday आहे, त्याच्यानंतर रिलेशन is directly quantity of electricity, that is Q is directly proportional to their chemical equivalent of masses. काय असेल सांगा? Chemical equivalent of masses, not their atomic number. Try to write. Okay, Ahrekar, you correct answer regarding this. 40 gram, their chemical equivalent mass is 40, atomic number is 20. Very good. Now we see a next question. Okay, these are the some questions regarding this. Now we see a next part, or I share my screen. By finishing these 2 to 3 examples, we finish out the Faraday's laws of electrolysis. Now we see next concept regarding this. I think first we see a syllabus for us. See, this is the syllabus. This electrolysis we finish out. Then Faraday's laws we finish out. Then first, before starting this unit, I give information regarding basic principles of electroplating. जे बेसिक प्रिन्सिपल आहेत ते सगळे मी संपवलेले आहेत. आता नाव वी फोकस ऑन दिस कॅथोड करंट एफिशियन्सी. नाव वी फोकस ऑन cathode. What is mean by cathode current efficiency? How we calculate this current efficiency? What are the benefits of this cathode current efficiency? And if there is higher or lower cathode current efficiency, then what will happens? What we do? Before starting this, I give one example to solve you. Then we try to solve the example. This example, I think screen is visible to all of you. Solve this example, then we go to next slide. हे जे एक्झाम्पल आहे ते प्रत्येकाने सॉल्व्ह करायचं. एक्झाम्पल सर्वांना दिसतंय का आता? हाऊ मेनी ग्रॅम ऑफ ऑक्सिजन इज लिबरेटेड बाय इलेक्ट्रोलायसिस ऑफ वॉटर आफ्टर पासिंग दिस वन इज एक्झाम्पल. पटकन सॉल्व्ह करा, मला फायनल आन्सर पाहिजे. ट्राय टू सॉल्व्ह दिस एक्झाम्पल. केलं का सॉल्व एक्झाम्पल? हे 2-3 एक्झाम्पल आहेत. सिंपल एक्झाम्पल आहे. सगळं दिलेलं आहे तुम्हाला. किती ग्रॅम एम दिलेला आहे आणि झेड तुम्हाला काढायचा आहे. इलेक्ट्रोकेमिकल एम इज इक्वल टू झेड आय टी. टाइम दिलेला आहे, करंट दिलेला आहे. कोण सॉल्व करते का एक्झाम्पल सांगा जरा मला. ट्राय करत असेल, यू कॅन सॉल्व दिस एक्झाम्पल लेटर. Now see here this new concept regarding cathode current efficiency or how to calculate this cathode current efficiency. The ratio of, see here, the ratio of, it is also included in definition point of view in your syllabus. The ratio of weight of metal, the ratio of weight of metal actually deposited, weight of metal actually deposited to that which would resulted if all the current had been used for deposition is called as cathode current. परत एकदा मी डेफिनेशन सांगतोय बा. पहिल्यांदा आपल्याकडे मेटल किती होतं की आपण दुसरं डेफिनेशन पाहूया याच्यापेक्षा सिंपल. cathode efficiency or cathode current efficiency is simply, we can write in the formula type. A cathode efficiency is simply calculated by actual weight of metal deposited. आपण एक एक्झाम्पल पाहणार आहोत. कॅथोड करंट इफिशियन्सी काय आहे? ऍक्च्युअल वेट ऑफ मेटल डिपॉझिटेड. ज्या कॅथोड वरती आपण काय करतोय? मेटल डिपॉझिट करतोय. ऍक्च्युअल वेट ऑफ मेटल डिपॉझिटेड डिवाइडेड बाय theoretical weight of metal as per Faraday's laws. कॅथोड वरती किती, पहिल्यांदा आपण सपोज बिफोर मेकिंग कॅथोड इफ वी टेक वेट ऑफ दिस cathode and after electrolysis and electroplating if we take weight, then how much quantity of, what is the variation between before and after? By subtracting we get a actual metal deposited on the cathode divided by theoretical weight of metal as per Faraday's law. By using Faraday's law we can calculate theoretical weight. By using Faraday's law we can calculate their theoretical weight. Then how to calculate Faraday's law? How calculate as per, how we calculate the theoretical weight by using Faraday's law? This is the formula. A into W into I into T into E divided by V upon F. See here, what is the, sorry, not A and W are different, there is same. What is AW? AW is the atomic weight of मेटल बिन जोडलेलं. atomic weight जोडलेलं म्हणजे atomic mass there is difference. जसं आपण कॅल्शियमचा atomic number 20 आहे पण atomic mass 40 असते. ऑक्सिजनचा atomic number 8 आहे पण atomic mass 16 आहे. या टाइप मध्ये atomic weight into I means काय घेणार आहे आपण इथं? करंट. किती करंट आहे तो? T means टाइम, E means cathode efficiency, percentage current हे तुम्हाला दिलं जाईल. पर्सेंटेज ऑफ करंट दॅट डिपॉझिटेड ऑन दी मेटल, किंवा हे आपण पर्सेंटेज काढलेलं असेल. आपण 60%, 40% किती अमाऊंट मध्ये डिपॉझिट झालेलं आहे. अजून काय राहिलं इथं? व्ही मीन्स व्हॅलन्स, दॅट इज व्हॅलन्सी नंबर आपण मला पाहिलंय. AlNO3, ॲल्युमिनियमची 3 व्हॅलन्सी होती. कॉपर सल्फेट CuSO4, कॉपरची 2 होती. त्या टाइप मध्ये व्हॅलन्स. आणि एक इज दी फॅराडे कॉन्स्टंट. हे रिलेशन आहे, याला म्हणतो आपण. हे सगळे फॉर्म्युल्यामध्ये टाकले. पहिल्यांदा तुम्ही काय घेतलेलं आहे? ऍक्च्युअल मेटलचं वेट असेल तुमचं. ऍक्च्युअल वेट ऑफ मेटल डिपॉझिटेड डिवाइडेड बाय हे ऍक्च्युअल वेट. त्याला आपण डिवाइड कशाने केलेलं आहे? थेरोटिकल वेट. ते कसं कॅल्क्युलेट केलं? atomic weight into how much quantity of current pass into time t into E means cathode current efficiency, that is how much percentage of metal is deposited, divided by V means valence number of electrons and A means Faraday constant, that we called as a actual constant आहे तो आहे 96,485, पण आपण त्याला 96,500 घेत असतो. याला म्हणतो आपण कॅथोड इफिशियन्सी. याच्यावरून आम्ही एक्झाम्पल तुम्हाला MCQ ला जर तुमची जर ऑनलाईन मोड मध्ये एक्झाम झाली तर काय विचारू शकतो? कॅथोड इफिशियन्सी इज सिम्पली कॅल्क्युलेटेड बाय डिवाइडिंग ऍक्च्युअल वेट and theoretical weight, dividing actual weight by theoretical weight by actual weight by both methods and none of these. असे काहीतरी ऑप्शन असतील. मग कशाला आपण ऍक्च्युअल वेट ऑफ मेटल डिवाइडेड बाय theoretical weight हे तुम्हाला माहित असावं. पुढे दुसऱ्या एका फॉर्म्युल्याने सुद्धा आपण कॅल्क्युलेट करू शकतो. पण आय थिंक दिस फॉर्म्युला इज व्हेरी सिंपल. जो आपण पहिला फॉर्म्युला जो पाहिला हा सिंपल आहे. हा सुद्धा मी तुम्हाला दाखवतोय. हा जो फॉर्म्युला आहे हा जराशी कॉम्प्लिकेटेड आहे. परत पहा, कॅथोड करंट इफिशियन्सी याला म्हणतो आपण F पर्सेंट वॉज कॅल्क्युलेटेड बाय युजिंग फॅराडेज लॉ. कसं कॅल्क्युलेट केला? F इक्वल टू हे W म्हणजे काय असणार आहे? वेट डिपॉझिटेड. म्हणजे W इज द एक्सपेरिमेंटल वेट ऑफ द डिपॉझिट. वेट डिपॉझिटेड डिवाइडेड बाय WT into 100. WT इज द theoretical weight of the deposit into 100. पण ते WT कसं काढायचं? तर त्याला परत फॉर्म्युला आहे हा. WT is the theoretical weight. The theoretical weight of individual metal calculated as WT is equal to Q. परत Q is equal to I into T. तो फॉर्म्युला पहिला आहे, त्याच्यामध्ये आपण सगळे कन्व्हर्जन टाकलेले आहेत. Q is equal to I into T आपण मगाशी घेतला असतो. डिवाइडेड बाय इक्विव्हॅलंट वेट ऑफ मेटल इक्विव्हॅलंट वेट ऑफ मेटल डिवाइडेड बाय फॅरेडेज क्वांटिटी. आणि इकडे जर तुम्ही गेला तर तेच आहे पहा. इक्विव्हॅलंट वेटच्या ऐवजी इथं काय घेतलेलं आहे, व्हॅलन्सी घेतलेली आहे. म्हणजे हा तुम्हाला फॉर्म्युला वापरायला खूप सोपा आहे. इथं तुम्ही atomic weight into current into time into E means percentage of metal deposited divided by V is the valence. तिथं इक्विव्हॅलंट वेट घेतलेला आहे आणि F is the फॅरेडे. यू कॅन यूज, हा सुद्धा सिंपल आहे, तुम्हाला जो आवडेल फॉर्म्युला तुम्ही यूज करू शकता याच्यावरती. जर इफ your exam is offline mode, then we ask the questions regarding numericals regarding this. But if exam is not in offline mode, then in online mode we cannot give example on this, because it is not simple task to calculate a whole thing in very small time. And hence in MCQ type of exam we can ask the formulas, but in offline mode we give example regarding this. Again, see, cathode current efficiency is simply calculated by actual weight of metal deposited divided by theoretical weight. आणि इथे आपण फॅरेडेज लॉने कॅल्क्युलेट केलेला आहे. theoretical weight कसं कॅल्क्युलेट केलं, there is a formula: atomic weight into current in ampere into time in second into percentage of current the deposit on the metal. These are the all things regarding this. After this, this is regarding cathode current efficiency. After this, we focus on a new concept. See here, cathode current efficiency basic principle, then cleansing of particles. Cleansing of how? Before electroplating, if we properly clean the particular cathodes, anodes, then electroplating is better, and we can increase the life of particular object of before cleaning. जर आपण जर क्लिनिंग केलं इलेक्ट्रोप्लेटिंग करण्याच्या अगोदर, तर we can increase the life of particular object. I think we see there are too much applications of this electroplating, and hence cleansing is a must. Then there are, I share this PDF. These are the some standard guidelines. Clean the metal prior to electroplating. Before electroplating, why we clean this? In this, they focus on why we clean the performance and quality of electroplated article depend upon the surface cleanness. See here, the performance and quality of electroplated article depends upon the surface clean lines and condition. Various metals are electroplated for decorative, in engineering purpose, for finishing. The common electroplates applied are usually, which are the common? Usually copper, nickel, chromium for decorative and functional uses. Electroplating articles are used in many industries, such as, you have idea regarding where we use this electroplating? Because we see some part. In this PDF, you see, if you not properly clean the particular object before electroplating, then we cannot adhere, fix. आपण सिंपल एक्झाम्पल घेऊया. आपल्याला जर कॉपरचं इलेक्ट्रोप्लेटिंग करायचं आहे, आपण मेथड पाहिलेली आहे, कॅथोड, एनोड आणि कॉपर सल्फेट. मला कॉपर Cu++ किंवा कॉपर इन दी इलेमेंटल फॉर्म, इन दी सॉलिड फॉर्म, कॉपरच्या कॅथोड वरती मला प्लेट करायचा आहे. इफ यू नॉट प्रॉपरली क्लीन दी कॅथोड बिफोर इलेक्ट्रोप्लेटिंग, तर त्या कॅथोड वरती जर थोडीशा, इफ दिस कॅथोड इज गोज रस्टिंग टेक्स प्लेस, जर तो कॅथोड व्हेरी क्लीन नसेल, त्याचं रस्टिंग झालेलं असेल, अँड बिफोर दिस क्लिन्झिंग we make it as a cathode and follow the principle of electroplating. Then electroplating of particular electrolyte containing element takes place on this cathode, but we cannot getting very smooth surface of this electroplated material. Why? Because the object or the cathode before electroplating is not clean. They have some rust, they have some dirt on the surface of this cathode rod or electrode, and hence cleansing is must. Adequate cleaning requires proper combination of cleansing procedures. Then what we use for clean this, आपण क्लिनिंग करण्यासाठी काय यूज करू शकतो? You all having idea regarding jewelries. If we go to the jewelry shop and if we clean the particular jewelries or ornaments in jewelry shop, they use a mixture like aquaresia. जर आपण एखाद्या ज्वेलरी शॉप मध्ये गेलो, जो सराफ आहे, जो सोनार आहे, त्याच्याकडे आपण पर्टिक्युलर आपले जे दागिने आहेत ते दिल्यानंतर बिफोर अँड आफ्टर जर तुम्ही जर वेट केले, देयर इज समवॉट लॉस इन वेट टेक्स प्लेस. व्हाय लॉस इन वेट टेक्स प्लेस? बिकॉज फॉर क्लिन्झिंग दे यूज aquaresia. There is 1 to 3% of HCl and HNO3, concentrated hydrochloric acid and nitric acid. Some quantity of this gold, silver, platinum, rhodium, whatever may be the elements used in jewelries, they some amount they dissolve with dust. डस्ट पार्टिकल तर डिझॉल्व्ह होतातच, ते तर रिमूव्ह होतातच, पण त्याच्याबरोबर कोण डिझॉल्व्ह होते? सम अमाउंट ऑफ दिस element, and hence there is loss in weight takes place, and hence proper cleansing for electroplating is must. If you want to electroplate a particular object, then cleansing is must. See here again, they call the choice of this procedure must be based on the knowledge of the metal to be clean. आता जर आपल्याला जर कॉपर क्लीन करायचं आहे आणि मी जर त्याला जर क्लीन करायला जर सोडियम क्लोराईडचं जर सोल्युशन घेतलं, मला काही माहित नाहीये कुठला एलिमेंट कशाने क्लीन केला पाहिजे. जर मी कॉपर सल्फेट कॉपरचा कॅथोड आहे, त्याला मी क्लीन करायला जर सोडियम घेतला, तर देयर इज अ formation of new complex, or there is formation of some metal complex like bonding between the sodium and copper, and we give a new alloy or mixture of element, and hence for cleansing there is a standard procedures must be and you must have a good knowledge regarding selection of different solvents or different metals in this solution form. A treatment to remove tarnish, light rust, fingerprints, or oxides is usually provided before immersion of the piece in the electroplating tank. इलेक्ट्रोप्लेटिंग करण्याच्या अगोदर त्याच्यावरती काय रस्ट आहे, फिंगरप्रिंट्स आहेत, काही क्रॅशेस आहेत, हे सर्व आपल्याला रिमूव्ह करावे लागतील. If we not clean the particular object in the proper form, then we cannot get a coherent, adhesive, uniform layer of electroplating on the particular object. This treatment activates the metal and usually accomplishes the acid baths, which also serve to neutralize the residual alkaline films on the cleansing purpose. Alkaline chelated. Chelation means I think you're not having idea. At FIBSC level, you see or you learn a transition element from which there is one word, that is chelation, that is Krebs law. Chelation. If we take ethylene diamine tetraacetic acid, if in your hand there is EDTA and to this add you calcium or magnesium, then there is a formation of a complex, and this type of complex is called as chelation. If you not follow the standard procedure of cleansing, or you have not idea regarding which element is cleaned by which method, which solvent is used, then what happens? काय होईल? There is formation of different types of complexes. पहा, डे टू डे लाईफ मध्ये जे हार्ड वॉटर आहे, सॉफ्ट वॉटर आहे, तुम्ही आय थिंक यू परफॉर्म एक्सपेरिमेंट ऑफ हार्डनेस ऑफ वॉटर. To calculate hardness of water, for this you use a EDTA in the burette, or you fill the burette by using EDTA. You pass the EDTA from the burette in conical flask. There is a solution containing calcium or magnesium. You add drop by drop by using, I think, the black indicator. At particular time, there is a formation of complex between this EDTA and calcium or magnesium, and there is and we reach at the end point of titration. ज्यावेळेस कॉम्प्लेक्शन तयार झालं त्यावेळेस एंड पॉइंटला आपण we can reach at that point. Therefrom, and if we not follow the standard procedure, if you want to clean the particular object in very properly, and you use instead of, if you want to use aquaresia and you use sodium hydroxide, तुम्हाला acid cleansing ला पाहिजे होता, तुम्ही त्याच्याऐवजी जर बेस वापरला, then there is 100% there is formation of one extra complex, and you cannot getting a proper electroplate on the particular cathodic rod, and hence these procedures are must. There are several stages to provide adequate cleansing. The stages are discussed in 3 parts. See here, त्याच्यासाठी वेगवेगळे स्टेजेस आहेत. फर्स्ट स्टेज काय आहे, पार्ट 1 मध्ये प्री क्लिनिंग, यूज ऑफ सॉल्व्हंट, इमल्शन और अल्कलाइन स्प्रेज, वेगवेगळे स्प्रे वापरा, सॉल्व्हंट घ्या आणि तुम्ही क्लीन करू शकता. सेकंड स्टेज काय आहे, इंटरमिडिएट अल्कलाइन क्लिनिंग. सेकंड स्टेजला फक्त आपण अल्कलाइन क्लीन करतो, जर त्याच्यावरती जर काय ऍसिडिक इम्प्युरिटी असतील आपण जर अल्कली टाकली तर ते क्लीन होऊन निघतील. थर्ड स्टेप काय आहे, फायनल इलेक्ट्रो क्लिनिंग टू रिमूव्ह द ट्रेस सॉलिड्स अँड एस्पेशली अडहेरंट इम्प्युरिटीज. ज्या काही इम्प्युरिटीज ऍसिड आणि बेस किंवा सॉल्व्हंट वापरून निघालेले नाहीयेत त्यांना आपण इलेक्ट्रो क्लिनिंग न करता इलेक्ट्रो क्लिनिंगने त्या रिमूव्ह करू शकतो. आणि चौथा जो पार्ट आहे ट्रबल शूटिंग, that is you choose by using which method we can clean this particular object. There is your choice to select different types of solvents, different types of acids, different types of alkalis for cleansing the object with proper knowledge. Then there are some benefits regarding this also. If you want to electroplate chromium, then which method is used to, or which solution is used to clean the particular object before electroplating. In next lecture, today I give only information why there is cleansing. In next lecture, next presentation, we see a step-by-step detailed information regarding cleansing purposes, or why there is importance to clean the particular object before electroplating. हे सगळं आपण नेक्स्ट लेक्चरला स्टेप बाय स्टेप पाहणार आहोत. आज मी फक्त आयडिया दिलेली आहे. आज आपलं टास्क काय काय कम्प्लीट झालेलं आहे, थर्ड एंड सेकंड लॉ, देन देअर एक्झाम्पल्स, then the different types of formulas. Today's task is only Faraday's laws, and this cleansing purpose we start this, but we know not reach to the end point, and hence in next lecture again we start from this cleansing metals prior to electroplating. Before electroplating, what are the cleansing activities, and after this our most important part in this unit, that is electroplating of nickel and chromium. हा सगळ्यात शेवटचा पॉइंट असेल. पुढच्या लेक्चरला आपण फक्त काय पाहणार आहोत, त्यातलं डिफरंट टाइप्स ऑफ क्लिन्झिंग मेथड्स. Okay, by reaching this point we stop here. I can leave the call.